Good morning, friends. Today we are starting the new chapter, chapter 12, Exponents and Powers. So, we'll first revise what we have done in the previous classes, that are previous standard. First, we understand what is the power notation. So, as you can see here, we have got repeated multiplication. 2 into 2 into 2 into 2 into 2 is 2 is multiplied repeatedly 5 times. So it is written in the notation as 2 to the power 5 or 2 raised to 5. This notation is 2 to the power 5 or 2 raised to 5, where 5 is called the exponent or power and 2 is called the base. So because 2 is repeatedly multiplied 5 times, so we write it 2 raised to 5 or 2 to the power 5. Now as you can see, this base is 2 and power is 5. The base can be a positive integer or a negative integer. You have written minus 3 into minus 3 into minus 3 into minus 3. That is, minus 3 is multiplied 4 times repeatedly. So it is written as minus 3 raised to the power 4. Next you can see I have taken a fraction. 4 upon 5, 4 upon 5, 4 upon 5 is repeatedly multiplied 6 times. So it is written as 4 upon 5 to the power 6. Also I have taken an irrational number root 7, root 7, root 7, root 7, root 7 multiplied 5 times. So it is written as root 7 to the power 5. So this is the actual power notation. When any number is repeatedly multiplied, then the number of times it is multiplied, we write it as the power or the exponent. So this is how repeated numbers are written in the form of base and exponents. So I hope the first notation is clear to you. If not, try to thoroughly understand, only then we can move on to the next part. So when a number is repeatedly multiplied, then we write it as a power. So now 2 raised to 5 means 2 is repeatedly multiplied 5 times. Minus 3 raised to 4 means minus 3 is repeatedly multiplied 4 times. 4 upon 5 raised to 6 means the fraction 4 upon 5 is repeatedly multiplied 6 times. And root 7 to the power 5 means root 7 is repeatedly multiplied 5 times. So this is the power notation. The value, the evaluation we'll do in later lectures. But first of all, you have to thoroughly understand how we write the power notation. So I hope the first step is clear to you. This you must have done in the previous class also, but take it as a revision and understand this thoroughly. Now, in previous classes, we have also done this law of exponents. Now, what you can see here, a raised to m multiplied by a raised to n. What you observe here is that the base of both this is the same, the power is different. So when the base is same and the power is different and we are multiplying, it is equivalent to adding the powers. In the same way, when you divide a number by another number which can be expressed with the same base but different powers, then the division sign means the subtraction of the powers. In the third law, a raised to m, the whole raised to n, is a raised to mn, that is multiplication of the two powers. For the next law, we have a number with different base but same exponent. So here it becomes the multiplication of the two bases raised to the power n. Same way in division, if the base is different but the exponent or the power is the same, then first we do the division of the numbers raised to the power m, and one last identity is a raised to 0 is 1. Now you must have thoroughly done this in the previous classes, but I will take the time and explain to you each law in slight detail so you will understand how these laws work. First we have the law of multiplication. A raised to m into a raised to n means the base is the same, the power is different. So the first example I have is 2 raised to 4 into 2 raised to 3. You can see the base of both is same, 2, the power is different. Okay. Now what is the meaning of 2 raised to 4? 2 raised to 4 means 2 is repeatedly multiplied 4 times. That is 2 into 2 into 2 into 2. You can see this 2 raised to 4 is 2 multiplied repeatedly 4 times. Into. So this is the sign given into, so I put the into 2 raised to 3. 2 raised to 3 means 2 is repeatedly multiplied 3 times. So I have got this 2 raised to 4 into 2 raised to 3. Now you can see the base is the same. So what should the notation be? So count how many times the 2's? 1, 2, 3, 4, 5, 6 and 7. So this can be written as 2 raised to 7. Now what you follow from this is 2 raised to 4 into 2 raised to 3. Because the base is same, you just write down the base as it is and you add the powers like this. So because the base is same, a, and the powers are different, and there is a multiplication sign, you will put the same base as a and the powers you will add. So this is how it actually works out. But we write the short notation as a raised to m into a raised to n is a raised to m plus n. So if you can do this remaining on your own, minus 3 raised to 4 is minus 3 into minus 3 into minus 3 into minus 3. 4 times into minus 3 raised to 2, that is minus 3 into minus 3 2 times. So totally we have 1, 2, 3, 4, 5 and 6 written as minus 3 raised to 6. So once you understand this law, what is the law stating again? If the base is the same and it has to be multiplied, then we put the same base and just add the powers. So this is how the law is supposed to work. So now we can directly write this as 4 upon 5 raised to 2 into 4 upon 5 raised to 3. Since the base is same, 4 upon 5, 4 upon 5, the same fraction, I'll write the same base 4 upon 5 and the powers will add 2 plus 3. So this can be written as 4 upon 5 raised to 5. Next sum, root 7 raised to 2 into root 7 raised to 4 is same base root 7 raised to sum of the powers 2 plus 4 is root 7 raised to 6. So I hope this first law is very clear to you. When you multiply two numbers with the same base, we put the same base and only add the powers. So this is the simplified notation. The second law is for division. Again here the base is the same, the power is different, so we write a raised to m minus n. Okay, so because there is a division, we subtract the powers. Now in this subtraction there are two possibilities. Which are the two possibilities? The numerator m can be greater than n or m can be smaller than n. So let us see the first sum. How do we write it? 2 raised to 4. So 2 into 2 into 2 into 2. Divide by, this is division sign, so we write upon, because this can be also written as 2 raised to 4 upon 2 raised to 3. 2 raised to 3 means 2 into 2 into 2. So this 2 and 2 gets cut, this 2 and 2 gets cut, this 2 and 2 gets cut. So what remains is only 2 or 2 raised to 1. Now that could be written as 2 raised to m, that is 4 minus 3. So 4 minus 3, which also gives us 2 raised to 1. So if it is clear to you now, in the next we have minus 3 raised to 4, minus 3 raised to 2 divided. So I'll write minus 3 raised to 4 upon minus 3 raised to 2, which can be written as minus 3 into minus 3 into minus 3 into minus 3, that is 4, upon minus 3 into minus 3, that is minus 3 the whole square. So minus 3 and this gets cut, this gets cut. What remains is minus 3 into minus 3, that is minus 3 the whole square. So you can also get this by writing minus 3 the same base and subtracting the powers. So 4 minus 2 gives us minus 3 raised to 2. Now in the third question you can see in these first two questions this m4 was greater than 3. Here 4 was greater than 2. In the third question it is 7 raised to 2 divided by 7 raised to 6. Here m is lesser than n. So let us see what happens. 7 square divided by 7 raised to 6. So we have got 7 into 7 upon 7 into 7 into 7 into 7 into 7 into 7. So 1 and 1 7 gets cut and this gets cut. Now there is nothing remaining on the top, so we write 1, 1 ones are 1 upon 1, 2, 3, 4. 7 raised to 4. So the answer is 7 raised to 4. So 7 raised to 2 divided by 7 raised to 6 gives us 1 upon 7 raised to 4. Now if you wanted to write it in this form, what would we get? Let us check. Using this formula, we should get 7 raised to 2 divided by 7 raised to 6 is 7 raised to 2 minus 6. Why? Because this is the numerator 2 and this is in the denominator 7 raised to 6. So this formula states if you have to divide, it should be the base raised to m minus n. So 7 raised to 2 minus 6 is 7 raised to, what is 2 minus 6? Minus 4. Which means that 1 upon 7 raised to 4 is 7 raised to minus 4. Understand this very well. What is the concept of a negative power? What does a negative power actually mean? This is a very important concept in powers and exponent. What does a negative power mean? When do you get a negative power? You get a negative power when the numerator, the power of the numerator is smaller than the power of the denominator. Means when m is less than n, this m, the first number is less than n, then if you do m minus n, you get a negative number. So 7 raised to minus 4. When you get minus 4, when the numerator is lesser than the denominator. But if I do the proper method, I get 1 upon 7 raised to 4. So we can see that 1 upon 7 raised to 4 can also be written as 7 raised to minus 4. So remember this. So let us take an example. If I have got 5 raised to minus 2, it means I have to take the reciprocal. So this is actually 1 upon 5 raised to 2. Because the denominator was bigger than the numerator, I got a number in the denominator. When I take it to the numerator, then the sign of the power changes. So 5 raised to 3 can also be written as 1 upon 5 raised to minus 3. So this is a very important concept of powers and exponent. Remember, when a power in the numerator goes to the denominator, the sign of the power changes. If a power in the numerator goes into the denominator, the sign of the power changes, and same way, if the denominator, the power of the denominator goes into the numerator, the sign changes. Minus 3 becomes 3. So this is a very, very important concept. Kindly reconsider and understand. So 7 raised to 2 divided by 7 raised to 6 can be written as 1 upon 7 raised to 4, or can be written as 7 raised to minus 4 by using this method. But it is one and the same. So what you can see here, 7 raised to 4 is in the denominator. When you take the reciprocal and the number goes in the numerator, the sign of the power changes. Now look at this last one. Here, third case, m is equal to n. So we have root 7 into root 7, that is 7 raised to 2. Divide by 7 raised to 2, we have got root 7 into root 7. Your root 7 gets cut, so it becomes 1. Because we know that, say example, 9 upon 9 is 1. Similarly, 3 raised to 5 upon 3 raised to 5 is 1. Right? But if we use this formula, what do we get? If we use this formula, we should get 3 raised to 5 divided by 3 raised to 5 is equal to 3, same base, subtraction of power. So it is 3, 5 minus 5 is 0. So we get 3 raised to 0. But what you can see, we got the answer 1. So 3 raised to 0 is 1. So we come to a basic rule that any number a raised to the power 0 will always give us 1. This number a can be anything. It can be root 7, it can be 7 or whatever. So for example, suppose I have got 3 upon 5 raised to 0. The answer should be 1. Because anything raised to the power, how do we get it? When the power of the numerator and the denominator is same, after cutting we get 1. And on subtracting the powers also, we get raised to 0. So anything raised to 0 always gives us 1. This is a very, very important concept in powers and exponent. Remember, this is the law of exponent. I have explained to you how we get this, and this is the second law of division. Now next we have a raised to m raised to n. So we can see here 2 raised to 3 raised to the power 4. Now this is a power raised to a power. What does it actually mean? 2 raised to 3 raised to 4 means 2 raised to 3 is repeatedly multiplied 4 times. So it's 2 raised to 3 into 2 raised to 3 into 2 raised to 3 into 2 raised to 3. So what I have done here, I have taken this whole number as one number and raised to the power 4. So I got 2 raised to 3 into 2 raised to 3 into 2 raised to 3 into 2 raised to 3. Now you can see here the base is the same. Okay, and even the powers are same. But the base is the same and it is a multiplication. So what is the rule? We keep the base as it is and add the powers. So I add 3 plus 3 plus 3 plus 3. So I get 2 raised to 12. But I could even get 12 by multiplying 3 into 4. Okay. Let us expand and see. Are we getting the same answer? 2 raised to 3 means 2 into 2 into 2. Again into 2 raised to 3 means 2 into 2 into 2. Into 2 raised to 3 means 2 into 2 into 2. Into 2 raised to 3 means 2 into 2 into 2. Now count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Got 1, 2, 3, 4, 5, 6, 7, 8, 9. This is into 10, 11 and 12. So we get 2 raised to 12. So this is the total expansion. But remember this rule now. Something power raised to the power means the multiplication of the two powers. So this can be now directly written as minus 3, that is the base, raised to the power 10. You can write the full notation or directly 5 2s are 10. Similarly, 4 upon 5 is the base. Yes, 2 4s are 8. So we write 2 4s are 8. Now, 4 upon 5 raised to 8 can also be written as 5 upon 4 raised to, can any of you tell the answer? Minus 8. How we get this? We can write 4 upon 5 raised to 8 as 4 raised to 8 upon 5 raised to 8. Now I take this number to the numerator, so sign of the power will change. I take this number to the denominator, sign of the power will change. It can be written now as 5 raised to minus 8 upon 4 raised to minus 8. Since the power is the same, I will write 5 upon 4 raised to minus 8. So when the number becomes a reciprocal, the sign of the power changes. That we'll see in the next slide. What have we got here now? In this case, the base is different, but the power is the same. So say the simplified answer is multiplying the bases and then putting the power. So let us verify this. 2 raised to 4 into 5 raised to 4. Now 2 raised to 4 is 2 into 2 into 2 into 2. And 5 raised to 4 is 5 into 5 into 5 into 5. So we have got 2 5s are 10. Again 2 5s are 10. So into 10 into 2 into 5. I am pairing them up. 10 into 2 into 5. That is into 10. I got 10 raised to 4. Yes, 10 into 10 into 10 into 10 is 10 raised to 4. What does it mean? That because the power is the same, I kept the power same. And base I have to multiply a into b, so I did 2 into 5. So 2 5s is 10, so 10 raised to 4. So I hope you can do the others in the same way. Minus 3 raised to 4 into 2 raised to 4 can be written as minus 3 into 2 raised to 4. Now minus 3 into 2 is minus 6. So this becomes minus 6 raised to 4. Here we have got 4 upon 5 whole square into 3 upon 5 whole square. So first I'll multiply the base. 4 upon 5 into 3 upon 5, and I keep the power m the same, that is square. So I get 4 3s are 12, 5 5s are 25 whole square. And root 7 square into root 3 square can be written as root 7 into root 3 the whole square. Root 7 into root 3 is root 21. You will not understand this because you have not done irrational numbers, but just remember that the power of exponent, yes, this power, this law works for all numbers. This is not of the part of your syllabus right now, but I am showing you just to make you understand that the rule works for positive integers, negative integers, fractions, and even irrational numbers. So the rule remains valid for all the numbers. Okay? In the same way for division, if the base is different but power is the same, we can first divide the numbers and then put the power. For example, 6 raised to 5 can be written as 6 into 6 into 6 into 6 into 6. Upon 2 raised to 5 can be written as 2 into 2 into 2 into 2 into 2. Now you can do 2 1s are, 2 3s are, 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 and 2 1s are, 2 3s are. So we get 3 raised to 5 upon 1, that is 3 raised to 5. Now how can I apply this law? 6 raised to 5 upon 2 raised to 5 can be written as a upon b, that is 6 upon 2 the whole raised to 5. But I know 2 1s are 2 and 2 3s are, so I get the answer 3 upon 5. So this basic rule states that if the power is the same but the bases are not the same, first divide the numbers and then write to the power. So this can be written as minus 8 upon 4, the division of the bases first, raised to the power 5, because the power is the same. I get 4 ones are 4 twos are, so I get it minus 2 raised to 5. So here I have tried to explain to you all the law of exponents, yes, and also introduce the new concept of negative power. So you have to rewind this video and see, you have done this in your previous classes. But all these laws should be thorough to you. Only if you understood all these laws thoroughly, then this chapter will be very easy for you. Before we move anywhere ahead, kindly try to rewind the video and understand all this concept in detail. Now, what is multiplicative inverse? Now we know the identity of multiplication is 1, right? So suppose you have got a number 5. What will you multiply with 5 to get 1? So we multiplied by the reciprocal, we multiply by 1 upon 5. So 5 and 5 get cut, what remains is 1. Suppose you got the number 2 upon 7. What will you multiply by 2 upon 7 to get 1? You will multiply it by 7 upon 2. 2 and 2 gets cut, 7 and 7 gets cut, and we get 1. So to get the multiplicative identity 1, we multiply the number by its reciprocal. Reciprocal means 1 upon the number. So a raised to minus m, yes, is 1 upon a raised to m. So this a raised to minus m is called the multiplicative inverse. So a raised to m and a raised to minus m are multiplicative inverse. For example, the first one we have 2 raised to minus 4. Now, what should I multiply it by to get 1? So I multiply it by the reciprocal. That is, I write 1 upon 2 raised to minus 4. So this both gets cut and I get the answer 1. But this number, that is 2 raised to minus 4, sorry, 1 upon 2 raised to minus 4 is the number. Now you remember the rule of negative powers. If you take it on the top, it becomes positive. So 2 raised to 4 is this number. So the multiplicator inverse of 2 raised to minus 4 is 2 raised to 4. So in the same way, the multiplicative inverse of minus 3 raised to minus 3 is minus 3 raised to 3. This is the multiplicative inverse of the number. So the multiplicative inverse is given as a raised to minus m and a raised to m are the multiplicative inverse of each other. So the multiplicative inverse of 3 raised to 5 raised to minus 5 is 3 raised to 5 raised to the power 5. So what you can see, in the multiplicative inverse, the base remains the same. Only the sign of the power changes. If it is negative, it becomes positive. If it is positive, it should become negative. So the multiplicative inverse of root 7 raised to minus 2 is root 7 raised to 2. In the similar way, the multiplicative inverse of 3 raised to 5 should be 3 raised to minus 5. So in multiplicative inverse, the base remains the same, only the sign of the power changes. Now, we'll go to place value. So this you have done in the earlier classes. 2 is in the units place, 3 is in the tens place, 6 is in the hundred place, and 7 is in the thousand place. This is the thousand place, this is the hundred place, this is the tens place, and this is the units or ones place. This is the thousands place. Now, how do we read this number? This number is 7632. So the unit space is 2. So what is the meaning of unit? Unit means 1. So written 2 ones are 2. Now I told you 2 is written as anything raised to the power 0. Here we are following the decimal system, so it is written as 2 into 10 raised to the power 0. The next digit 3 is 30. 30 is in, yes, 30 is the tens place. So 30 can be written as 3 into 10. That will be as 3 into 10 raised to power 1. So we are writing this now in decimal notation. The units digit is written in the power 10 raised to 0. The tens digit is 10 raised to 1, that is 10. You can see. The digit in the hundreds place is written as 600. that is 6 into 100. But what is this 100? 100 is the power 10 raised to 2. So the one in the thousands place, that is 7000, is 7 into 1000. So in the thousands place there is 1000, which is 10 raised to 3. So now we will follow the units place has got 10 raised to 0, that is 1. Tens place has got 10 raised to 1, that is 10. Hundreds place has got the power 10 raised to 2, that is 100. And thousand place has got the power 10 raised to 3, that is 1000. So now we are writing the place value as power and exponents of 10. Why we have taken 10? Because 10 is the base of a decimal system. The word deca in Latin means 10. So decimal system uses the base 10. So what is a decimal system where we write everything in 10? So 20, this number 7632. We say 7000. 1000 is 10 raised to 3. 600. 100 is 10 raised to 2. 30 is 3 into 10. 30, 10 raised to 1 and 2. So in decimal system we use this notation. So try to understand this notation. Now, what happens to the numbers which are decimal numbers? Yes, the digits after the decimal point. For example, you got 0.1. We know 0.1, there is one digit after the decimal point. We write as 1 upon 10. The first digit after decimal point is the 10th digit. It is not tens, it is the 10th digit. 0.1 is written as 1 upon 10. 10 can be written as 10 raised to 1. Now 10 raised to 1 when taken to the numerator becomes 10 raised to minus 1. So for example, we have got the number 0.3. 0.3 means 3 upon 10 or 3 into 10 raised to minus 1. The first digit after the decimal point is the 10th digit, which is given by the power notation 10 raised to minus 1. The second digit after the decimal is called the hundredths digit. DTHS, hundredths digit. 0.01 is 1 upon 100. Now what is 100? It is written as 10 to the power 2. 10 times 100, so 10 square. So this digit in the numerator becomes 10 raised to minus 2. So 0.02 is 2 upon 100 or 2 into 10 raised to minus 2. 10 raised to minus 2 means this digit is the second point after the decimal. In the same way, the third digit after the decimal, since there are 3 digits, we write 3 zeros below, that is 1 upon 1000. So 1000 is the 10 raised to the power 3 because 1000 is 10 into 10 into 10. So this becomes 10 raised to minus 3. So this number 0.007 is written as 7 upon 1000 or 7 into 10 raised to minus 3. 10 raised to minus 3 means the third digit after the decimal point. So before the decimal point all the powers are positive. After the decimal point all the powers are negative. So if you understood till here, then we'll do this sum. So how should we write the expanded notation of this sum? So it is 3000. So 3 into 1000 is written as 10 raised to 3 plus 700. So it is 7 into 100. 100 is 10 to the power 2 plus 50. That is 50 is 5 into 10 or 10 raised to the power 1 plus 6. That is 6 into 10 raised to the power 0 plus, after decimal the first digit is 3, so I'll write 3 into 10 raised to the power minus 1 plus, the second digit is 2, so I'll write 2 into 10 raised to power minus 2. So what you can see, before the decimal point the powers are raised to 0, 10 raised to 0, 10 raised to 1, 10 raised to 2, 10 raised to 3. After decimal it is 10 raised to minus 1, 10 raised to minus 2. So if you go further it will become raised to the power 4, raised to the power 5. So 10,000 raised to the power 4, lakh is 10 raised to the power 5, 10 lakh is raised to the power 6, crore is raised to the power 7 and so on. So the next number you can try on your own. Pause the video here, write it on your own, then check my solution. This will become 1 into 10 raised to 3 plus 0 into 10 raised to 2 plus 4 into 10 raised to 1 plus 3 into 10 raised to 0 plus 5 into 10 raised to minus 1 plus 2 into 10 raised to minus 2 plus 7 into 10 raised to minus 3. This is the expanded notation system. Yes, where you've got positive integers also and negative integers also. So this is what we have done today, a little bit of revision from the previous class, and the new concept here is the power a negative exponent. Kindly see the video again, even if you have to repeat it 2-3 times. Understand this concept very thoroughly. If you understand this concept, then the remaining chapter will become very simple for us. So in the homework I have given, revise the law of exponents by using 3 examples each. So you can rewind the video and every time pause the video and do it using 3 examples each, examples of your own. I have used some notations, but you will have to use your own examples to understand this thoroughly. I am ending the lecture here, hoping that you will rewind the video and watch this video 3 to 4 times and understand the concept of power and exponents in complete detail from the very beginning. Thank you.